Good afternoon, everyone. My name's Heresh, and this is Petroleum Engineering Kurt channel from YouTube. There's also an Instagram page with the same title. I hope you'll check it out. Our objective here is to share knowledge and information about petroleum engineering, and today's no exception. Today we'll be talking about kicks and their occurrence during drilling operation. So I hope you'll find it beneficial and interesting. Before we get started with the lesson, I wanted to tell you this, that I will explain this presentation in English language, and then my partner, Mr. Safin, will explain it in Kurdish language so that you can have a basic understanding of what we're talking about here. Alright, so this is the list of content. In this presentation we'll first give an introduction to what the kicks are, and then we'll be talking about how kicks occur, and then what causes the kicks to occur. There are actually more than four factors that causes a kick to happen, but because we're talking fundamentally here, so we'll only talk about the basic ones. These four are the basic ones, the most common causes of kicks. Then we'll talk about primary and secondary indicators of kicks. These are some observations in which a kick is happening. Then we'll talk about procedures taken in case of a kick. In other words, what should be done in case of a kick. Then finally we'll talk about two methods in which we can stop or kill a kick, which is weight and weight method and driller's method. Alright, so this is the introduction. Well, in order to get a better understanding of kick definition, we first have to know the meaning of some specific words and terms. Well, look at this figure. You see, this is the wellbore, and the area around the wellbore is called the formation, and the fluids inside the formation are called the formation influx, and the fluid inside the wellbore is called the mud. The mud exerts the hydrostatic pressure on the walls of the well, and the hydrostatic pressure restrains the formation influx from entering the wellbore. Well, in any case where the hydrostatic pressure fails to restrain the formation influx, then the formation fluids will find its way into the wellbore. And this intrusion of formation fluids or formation influx is called a kick. Well, so far we know that the formation influx is the fluid inside the formation, any type of fluid, and the hydrostatic pressure is the pressure exerted by mud column and its density, and a kick is the intrusion of formation influx into the wellbore. Well, you see, for a kick to occur, the formation must be porous and permeable. As you can see from the figure, the formation is porous and permeable. It's porous to contain the fluids, the influx, and is permeable so that the influx can move into the wellbore. Well, and the second, the formation must contain fluids. Well, you see, if there's no fluids, then there will be no intrusion of influx into the wellbore. In this case, there will be no kick. So for a kick to occur, the formation must also contain fluids, along with being porous and permeable. The third one is the formation pressure must be greater than the hydrostatic pressure exerted by the mud column. Well, as you can see in this figure, the blue lines represent the pressure of the formation influx, and the black arrows represent the hydrostatic pressure. And since the formation pressure is greater than the mud's hydrostatic pressure, well, in this case, a kick is happening. Okay, so basically, when the hydrostatic pressure becomes less than the formation pressure, and the formation is porous and permeable and contain fluids, in this case, a kick will occur. Well, the formation influxes are usually brine water, crude oil, and natural gases. Alright, so let's talk about the occurrence of kicks more specifically on this slide. And let's talk about it on this figure. Well, you see, when we are drilling through a formation that is porous, permeable, and fluid bearing, the hydrostatic pressure of the mud column will try to restrain those fluids from entering the wellbore. Well, you see, this is the formula of hydrostatic pressure. It depends on density and the height of the fluid. And g is the acceleration due to gravity, which is 32.70 feet per second square. And this is constant. So that's why we're going to exclude it from the formula, and we're only going to focus on density and height of the fluid. Technically, we're talking about mud here. Well, in any event or in any case where the formation pressure becomes greater than the hydrostatic pressure, the formation fluids will enter the wellbore, and in this case, a kick will occur. And during this kick, the formation fluids will be contaminated with mud. This is called mud contamination. This is another very serious problem because the hydrostatic pressure was already low for the kick to occur, and then when the mud is contaminated, the density of the mud will decrease. So it's a given that the hydrostatic pressure will decrease even more and more rapidly. And when this happens, the density of the mud will be insufficient to remove the cuttings from the bottom of the well up to the surface. This is called insufficient removal of cuttings. And when this continues, when the formation fluids continuously enter the wellbore, the kick will finally become a blowout. So that's why once a kick is detected, the well should be closed, should be shut in, because the kick events are very serious, a very serious problem. Alright, so from now on, we'll talk about the events and circumstances in which the hydrostatic pressure is lowered, because these are the events or circumstances in which a kick is occurred. Alright then, so let's talk about some major events and circumstances in which the mud hydrostatic pressure decreases. One of these events is insufficient mud density or weight. Well, this is also called mud imbalanced. When the mud is imbalanced, this means that the formation pressure is greater than the wellbore pressure. And wellbore pressure is just another word for hydrostatic pressure. They are the same thing. Well, this insufficient mud density is a result of two factors. Either the mud properties are poorly dealt with, for example, maybe the concentration of clay in mud is not as much as it should be, or because of some other reason. Because, clay is a main ingredient for increasing mud density. And therefore, if mud density is low, then proportionally we'll have a low value of hydrostatic pressure, as it's obvious from the formula. So the second factor is when we suddenly drill through an abnormal formation pressure, since these sort of formations have a great pressure level. So it's most likely to cause a breach in wellbore pressure and result in a kick. Well, the second event in which the hydrostatic pressure is decreased is when there is a loss of circulation. A loss of circulation is when mud is lost into a fracture, a caving, or a permeable formation. Well, as you can see from the figure that this is a kick occurring, this is a loss of circulation occurring, in which mud is lost into the formation. Well, during the loss of circulation, the level and the height of the mud inside the wellbore is decreased. Well, take a look at the formula. When the h is decreased, the height is represented by h. So when h decreases means when the level or height decreases, then proportionally the hydrostatic pressure is decreased. And then the formation pressure becomes greater than the hydrostatic pressure, and the influx flows into the wellbore, and a kick occurs, and then mud is contaminated with the influx. Well, the third event is improper hole fill-up during trips. And technically, a trip is when we pull the drill string out of the wellbore, maybe because we need to inspect the bit, or maybe we need to change it, or maybe for some other reason. However, when a drill string is pulled out, the level of mud inside the wellbore will decrease in prior to the volume of string being removed, as you can see from the figure. You see here? The drill string is removed, and in prior, the level of mud is decreased. And this will cause the hydrostatic pressure to decrease because H will decrease. You remember the formula, right? The hydrostatic pressure is proportional to H, to height of the fluid. If we want to prevent this, then we have to add up an equivalent amount of mud to the wellbore as the drill string is pulled out. Or in other words, the level of mud should always be maintained during the operation of tripping. That's the solution. Alright, so the last event is swabbing. This event is also connected to tripping because, swabbing occurs when a drill string is pulled out at an exceeded speed, at a high speed. Because if the drill string is pulled fast, then the wellbore will act like a pump and will suck the formation fluids into the wellbore, which we do not want that to happen. Well, to prevent this event from happening, actually the prevention is very simple. Just pull the drill string slowly at a standard speed and the well should be good. And that's the solution. Okay, so I guess that's enough for the first part because, I do not want to make this video very long. Therefore, we'll pick up where we left off in the second part. But before we end this, I just wanted to remind you that there's also a Kurdish version of this same presentation. So feel free to check it out. Alright then, take care all of you. Stay safe. Goodbye.